Hello, dear connections. Very good morning, and wish you all a great, happy, and fabulous New Year 2022. It's after a very long time that I have started recording these tutorials again. I am really sorry for that, but that last 2 years, it was like kind of Corona, and there were so many obstacles and like tensions, problems with everyone that I stopped it totally. So, welcome to the 10th episode of this tutorial. I promise you that going forward we will resume it and we will finish all these tutorials. So, in the ninth one, I had explained about the elements in the first station of progressive die. I am going to tell one more element, explain about one more element in the first station. This element is known as a stock alignment pin. I told you that we have stock guides which guide my coil in the die, but in the beginning when we set up the coil on the place, when we load them on the coil feeder, then we have to ensure that the coil is aligned to the die. So usually in absence of these pins, it takes more time for die setter to align the coil. They do some like heat and trial, but what we do here, we have one pin at the end of the die and one pin in the beginning of the die. These two are quite high, and when we start feeding the coil for setting, we make sure that my coil edge is aligned to these two pins. It means the both pin must touch my coil edge. As soon as it happens, it means the coil is aligned, right? And then we pull it back and we start feeding through the stock guides. That's easy, that saves times, and we keep these two stock alignment pin only on the one side, on the back side, not on the operator side but on the back side. So these are two stock alignment pins. Again, the material we prefer like CR12 or standard Misumi elements, whichever you feel like. Apart from these, we also have die button for pilot pairs in the first station, and we also have like a pitch notch in the first station. So let me show you the pilot pairs die button here. These are die button, and the size of the pierce hole is as per the standard. Some organizations want their pilot hole as 10 millimeters, some 12 millimeters, some half inches, kind of that. So these are a standard die button. These have a locking step, and these are fixed in the plate using a locking key. So this locking key will have one screw and one jack screw. Because these are a standard round profile, we don't fix the keys tight or precision. It just has to be there. If loose also is okay, because they just retain the die button. And the die button has to be precision slide fit. So if it gets damaged, if we have to replace it, we simply pull out the key and then we pull out the die button using our fingers or some small pins, right? Some headed pins. Let me show you the cross section of the die buttons. And let me also tell you, we use Dayton standard die button. All our die buttons are from Dayton, and based upon the customer standard, we will use either a tapered relief or a step relief. The material also, material and coating on the die button also will be as per customer standard, right? Okay. In case you have to make the die button locally, then you can use D2 material, but I would not advise it. Please buy from Dayton or whichever your standard suggests you. So let me show you how we fix the die button in the subplate. As you see, this die, we are not using any lifter plate, but we are using lifter pins and lifter bars, and everything is mounted in a big subplate, and that subplate is fixed to the bottom plate, right? So our die button is also fixed to this subplate. So let me show you the section here. That way you can see how we have fixed the die button and key in the subplate. So okay, over here, yes, let me rotate it a little and let me zoom it out. Okay, yes, so as you can see, we have a tapered, we have a step relief die button which is mounted in the subplate and is fixed using a key, a locking key through the locking step, right? Now you could see that in this particular die we had 3 pilot pairs, right? Everything depends on your strip layout. Now let me show you the pitch notch. Actually, when we feed the coil in the die, its progression is decided by the pilot pins, right? We did pilot piercing, and then the pilot pin will locate it precisely in the next station. But prior to that, we also do a rough pitch notch. So pitch notch are of 2 types: one small taper type and one full pitch cut. So this here we are using full pitch cut. So the cut of this trim line is equal to the pitch of the layout for this die. So it's a D2 steel, right? D2 steel 2 inches thick. It will have 2 screw, 2 dowel hole, and 1 jack screw. Again, we use, if it's metric, we use minimum like 2 M10 and 2 D10, right? Anyway, standard you can follow for that. And because it's only one side cutting, so to counter the thrust, we have provided one wear plate. So this is a standard 20 millimeter thick wear plates. Few people they provide 5 or 10 millimeter thick wear plate, but we always prefer 20 millimeter wear plate. Our upper trim steel first comes in contact with this wear plate, right? And then when it's located, guided, then it start cutting against that lower trim steel. So what happens? It absorbs the thrust. Now when the when my coil progress front side, this area will hit this hard stop. This is a hard stop, and this is a different kind of hard stop with provision for sensor also, right? So what happened? The whole thing we have made like CR12 material. So this particular which swings, it has a pivot provision in the center, and it has a spring. Against spring, it comes always in front condition, and when we move it, when we move the coil, it hits it and it make it hit the back of the holder, and the gap between photoelectric sensor and this hard stop increases, and that will give a signal to the press PLC that okay, yes, it has moved and the coil is in its correct position, right? If it didn't happen, then it will stop the press. Let me show you more in detail of this construction. So it's a standard like holder with three screws, 2 dowel, 1 jack screw, and this hard stop. This is like all will be like CR12 hardened one. This will have a okay. So this will have a pivot position in the center, which will like rotate, make it rotate. Let me make it transparent so that I can show you the position of spring. So you see this hole over here, right? The side of, yeah, this hole, right? In this hole we have a small coil spring. So that coil spring will keep this front piece moved outside always, right? So let's say, not always, let's say when we have cut it and upper die has moved up and the coil is moving forward, right? So that time, because there is no pressure over here, so because the spring force, it will be moved out, right? And the gap between photoelectric sensor and the end of this one will be very very less, right? Let me show you here like this. Let me make a sketch here. So this is the outline of the coil. It's moving, right? It's moving. Now when it will hit the green face of the hard stop, right? Prior to that, because the spring force, the position of the hard stop front area will be like this, right? Because the spring is outside the pivot area, so it will push it forward, so the back side will come in contact with the photoelectric sensor, right? When it will hit it, it will move it front, hit this edge of the hard stop holder, and the gap between photoelectric sensor and this end will be more. As soon as it will be more, certain, like up to certain gap, it will immediately give a feedback to the press PLC that yes, coil progressed, right? It's retained using a simple locking screw, right? So that is it. We have it's a wide strip layout, very big part. We have LHRS, so we have provided this both side. So you can see this is provided on the both side, on front and on back, right? Let me also show you a cross section of this, and you can see how we have retained this front piece of hard stop into hard stop holder. Okay, so we can take it a little front. Okay, so as you can see, this center area, which is machined like this, the locking is to hold it in the position. Now I know that many of you would be thinking it's a very complicated design here. It could have been made a bit simpler, but let me tell you, this is the standard what my customer prefers. This particular customer prefers, right? I can show you very simple such things, right? But anyway, now this one here, this is a second station, and this is a push for the pilot pins. Many customers, they prefer their simple clearance hole in the sub plate or in the lifter plate. Now lifter plate or sub plate are soft material, and your pilot pin will never be in contact with this hole, the wall of outer wall of this hole. But what happens, sometimes misfit happens and your coil may not be progressed correctly, and the pilot pin will puncture it. When it puncture it, then it will damage the holes, right? So that's why instead of keeping simple holes, we provide hardened bush. Bush may get damaged, may get broken, and we can replace it. We have locked using a small screw, preferably M10 or whichever as per standard. This has a step here. Just construction of this bush is just like that the pierce die button. It has a step and it holds, right? You can make it, and naturally, I discussed, it will be CR12. So that's all for today, and in the next 11 tutorial, we will discuss about trim steels, how we design trim steels, lower trim steels, and other elements which are in OP20 or other stations. Till then, thank you.